This is the beginning of part 3 of our module on credit-linked notes. We remind you that this part 3 contains chapters 3 and 4 of the module, with chapter 3 examining the risk sensitivities of CLNs and introducing the notion of correlation trading, and chapter 4 containing 6 quiz questions to test your understanding of these materials. This chapter 3 examines the risk sensitivities of CLNs and introduces the notion of correlation trading, which will play a critical role later in your understanding of CDOs and credit indices. By now, it has become clear that for each CLN, the spread under a risk-neutral framework is a function of the reference entity's default probabilities and recovery values, as well as the default correlation between the two reference entities. We can intuitively recognize, as we showed at the end of the preceding chapter, that any increase in the default probability of either or both reference entities will make the CLNs riskier, although to different degrees. So an investor that purchases either CLN at a given spread should find the price of that CLN decline if default probability rises for either or both reference entities. By the same token, any increase in recovery value for either or both reference entities will make the CLNs less risky. So an investor that purchases either CLN at a given spread should find the price of that CLN increase if recovery value rises for one or both reference entities. You might ask why the market might revise its views on recovery value from time to time. Well, the reference entity, for example, might be discovered to have significant amounts of off-balance sheet liabilities that were previously undisclosed, which would presumably reduce expectations for the recovery value following a credit event. Or a law might be passed that reduces the benefits to which terminated employees are entitled following a bankruptcy filing, which would presumably increase expected recovery value. Or finally, the reference entity might recapitalize itself by injecting new equity into its balance sheet and using the proceeds to reduce debt, which presumably would also lead to an increase in expected recovery value. Finally, we have seen that with an increase in default correlation between the two reference entities, holding both the default probability and the recovery value constant, the STD becomes riskier, but the FTD, first to default, becomes less risky. Using the trader terminology of long and short, where being long a risk factor essentially means that you have a gain if that risk factor increases, while being short means you would have a loss if that risk factor increases, we can draw a table to summarize the exposure of each CLN to the three risk factors we have identified: PD, RV, and correlation. The exposures for the investor in the column on the right confirm the discussion we just completed. For the issuer, in the middle column, you simply turn each long in the right column into a short in the left column, or rather the middle column, and vice versa. The more interesting question is how much each CLN reacts to a 1 unit increase in the relevant risk factor. If you have completed our module on Greeks, which covered principally FX options but applies to any other kind of option, you will recognize this present question as one that runs parallel to the calculation of delta, vega, and theta for options. Absent a standard terminology for the risk sensitivities in credit land, however, we will simply proceed to calculate what we will call the spread 01, recovery 01, and correlation 01 by analogy with the concept of DV01 or DV01 in the case of fixed income instruments. We open worksheet Greeks, which is essentially the same as the previous worksheet, except for this table you see at the bottom, in which we will show the results of our next calculations from the perspective of the note holders. We continue to assume that the CLNs have a 1-year maturity. We also assume that initially PD is 2% for each reference entity, RV is 40%, and that the estimated default correlation for the two reference entities is 20%, which puts us, as you can see, in column D as in David. Note that this brings the spreads of the first to default and the second to default to approximately 2.14% and 0.26% respectively. Finally, we recall that the impact of a 1 basis point increase in the necessary spread of a 1-year $100 million note, if we ignore time value of money, is quite simply that 1 basis point times the current value of the note. So the formulas for calculating our risk sensitivities should be easy to understand, such as the one, for example, that you see in the cell C24, and that is simply the difference between the old spread, which in this case we have typed into 4 decimals of accuracy, 2.1408%, and the new spread, both expressed in percentages, times 100 million, which is the notional in cell C27 that is not visible right now. To calculate first spread 01, we turn to worksheet spread 01, which is identical to the previous one, except that the columns for recovery 01 and correl or correlation 01 have been made invisible to avoid confusing us. We remind you that an increase in the reference entity spreads would cause the CLNs to become riskier, so we expect a mark-to-market loss under this scenario for both CLNs. To carry out this calculation, we need first to resort to a small trick. We cannot simply increase the spreads of the reference entities in cells C7 and C8 by 1 basis point, since those spreads are actually outputs in our model rather than inputs. The inputs, we remind you, are RV and the PDs. But we know that the spreads are simply 60% of the default probabilities. So working backward, our small trick is to simulate an increase in default probability of exactly 1.67 basis point, i.e. from 2% to 2.0167%, knowing that under our model this will cause the spreads of the REs, the reference entities, to increase by precisely 1 basis point, which is exactly what has happened and is the desired spread movement. Note, in a sense, we are attributing the entire 1 basis point spread movement of the reference entities to a change in the default likelihood and not to any change in recovery value. Having made this change, we observe a loss, as expected, of $17,714 for the FTD and a further loss of $2,326 for the STD in these two cells here in rows 24 and 25. You will note that we made both reference entity spreads in this example increase simultaneously and by the same amount, which we did not have to do. If we had wanted to calculate the mark-to-market sensitivities of the CLNs when only one reference entity widens by 1 basis point, we could have done so as well. As a practical matter, both measures are important from a risk control perspective and are sometimes referred to as the macro DV01 or macro spread O1 in the case of a simultaneous widening of spreads versus the micro DV01 or micro spread O1 for the case where one reference entity individually widens. Worksheet Recovery O1 enables us to do the same thing for a 1% increase in the recovery value, initially assumed to be, as you recall, 40%. Note that this time, an increase in expected recovery value reduces the CLN holder's risk, so should result in a mark-to-market gain. We proceed to input into the cell C6 the number 41% and confirm gains of $35,680 for the FTD and $4,320 for the STD. Again, it is the FTD that reacts more, since it is the note that is closest to the risk. Finally, we turn to worksheet Correlation O1 to simulate a 1% increase in the estimated default correlation between the two reference entities. We recall our earlier discussion that the FTD is long correlation while the STD is short correlation, and therefore expect a gain for the FTD and a loss for the STD when we increase default correlation. Inputting in cell D9 a correlation of 21% instead of 20% confirms a gain for the FTD of 11,760 versus an equal and opposite loss of the same amount for the STD, exactly as we intuited. This last result also points to a critical reality regarding the impact of default correlation on these two tranches. While their individual risk changes when correlation changes, the aggregate impact on the two tranches combined is zero, since the aggregate amount of credit risk of the two reference entities has not changed. It is only how the total loss in aggregate of the portfolio, as it were, is allocated among these two tranches that gets affected by the increase in correlation. Click pause to reflect on this point until you have fully grasped it, and then click play again. Worksheet summary, which has just appeared in front of you, summarizes our calculations in one single table and can serve as a basic tool for risk management purposes. A more advanced module on hedging a correlation book will show this in detail. You may recall that in our module Pricing Default Swaps, we showed how we can extract from the CDS spread and some assumed recovery value for the reference entity an implied default probability, being the probability that brings the CDS spread under the risk-neutral framework equal to the observed spread in the market. The FTD and STD notes enable us to do the same thing for default correlation, which we can therefore imply from the CLN spreads plus the individual CDS spreads and the assumed recovery values for the reference entities. To illustrate, suppose I observe the CDS spread for A and B at 300 basis points, the first to default spread at 497 basis points, and the second to default spread at 103 basis points, all for a one-year maturity, and finally assume that a recovery value of 50% is deemed just about right for these two reference entities following a credit event. We are asked to calculate the implied default correlation between A and B. For this task, we turn to worksheet Implied Correlation, which is essentially the same as worksheet CLN Pricing, but with one additional column, column E, which right now looks exactly like column D. The 50% assumed recovery value, which we now input in the right cell, combined with the one-year tenor, means that the default probability of A and B must be 6% given the observed 300 basis point spreads in the CDS market for A and B. Remember, this is our little trick from before. Having now inserted the 50% recovery value and derived the 6% default probabilities as well, I observe that the implied correlation between A and B must lie somewhere between 20% and 40%. Remember, the FTD has a spread of 497 basis points, which lies somewhere between these two cells I just highlighted, and the STD has a spread of 103 basis points, which again indicates that it lies between the two highlighted cells in row 20. Inevitably, we turn to goal seek in column E, which will require me to have the spread of the FTD equal to 497 basis points. Thus, tools, goal seek, set cell E19 equal to 4.97% by changing cell E9, which currently has the correlation at 20%. Hit enter, reveals a nice and round number for correlation of 30%. And note that both the FTD and STD are now correctly priced at this 30% correlation. A trader who believes this 30% number is too low and that it will eventually rise would wish to be long correlation, which he can do by purchasing the FTD as we explained before. A trader who believes this number is too high and will eventually fall would wish to be short correlation, which he can do by purchasing the STD, also as we explained before. If the market comes around to the view that the default correlation really should be 40%, the trader that bought the FTD would find herself owning that FTD with a spread of 497 basis points, but a yield of 469 basis points, so would achieve a gain of around 28 basis points on the principal amount of her investment. Conversely, if the market comes around to the view that the 30% correlation really should be 20%, the trader that bought the STD would find herself owning this instrument with a spread of 103 basis points, but a yield of only 74 basis points, so would achieve a mark-to-market gain of some 29 basis points on the principal amount of his investment. In both cases, of course, this would be true provided neither the individual default probabilities nor the expected recovery values also change. Our advanced dedicated module on correlation trading will explain how a trader can try to neutralize this residual exposure to spreads and recovery values in a manner very similar to how an options trader who goes long or short volatility can seek to be delta neutral to eliminate the residual exposure to the spot. For now, however, we have given you a basic idea of what the essence of correlation trading is. Differences in investor views regarding default correlation also give rise to attractive opportunities for a dealer's structuring desk. Suppose, for example, that in conversations with various investors, interest becomes apparent in an FTD and in an STD credit-linked notes based on two reference entities whose spreads are currently 200 basis points for a one-year tenor and whose recovery value following a credit event is expected to be 50%. Note that this implies a one-year default probability for each reference entity of 4%. The FTD investor, however, thinks that the appropriate default correlation is 60%, while the STD investor thinks that 20% is more accurate. This kind of difference in views on default correlation is somewhat plausible, perhaps not entirely, since there is no way to verify empirically or via a model what the exact number should be. The dealer buys bonds of the two reference entities or sells protection on them in the CDS market, thereby earning a spread of 2% on each. The dealer then issues the FTD at a 60% implied correlation, which means a spread of 2.77%, according to our model here. The dealer also issues the STD second to default at a 20% implied correlation, which implies a spread of 46 basis points, also according to our model. All in all, the average spread paid on the two notes is about 162 basis points, the average of this number here and this number here, and you can confirm this if you wish, versus the 200 basis points the dealer is collecting on average on the individual long positions that he has assumed, which leaves him with an aggregate profit of 38 basis points. The calculation of this average gain is set out here at the bottom in this very simple formula that takes the sum of the two revenues and subtracts the sum of the two expenses and divides by 2. Even more interesting, it is not in fact necessary for the dealer to have identified two investors whose desire is to purchase a first to default and a second to default CLN, respectively, on precisely the same two reference entities and for the same exact tenor and sharing the same view regarding expected recovery value. the dealer can issue those CLNs for which he has identified demand in the marketplace, perhaps only the FTD or perhaps only the STD, then calculate his Greeks from the issuance of whatever notes he has sold, and then seek to achieve neutrality of exposure to spread risk, correlation risk, and possibly recovery value risk by hedging himself in the OTC market using either individual CDS contracts or something known as standardized credit index contracts, which we will visit in a later module, and for which decent liquidity exists. Specifically, our module on correlation trading will teach you how the dealer can do this in quite a bit of detail. We conclude this module with a brief discussion of basket trades when the basket involves 3 or more reference entities. The elegant mathematics we were able to program into our various worksheets becomes unfortunately too complex once the reference entities in the basket reach 3 or more. This is principally because it is then no longer sufficient to work with joint default correlations, since scenarios would also need to be examined in which 3 or more reference entities default in the same time period. Practitioners and rating agencies have adopted a number of techniques to address this situation, most of which are based on Monte Carlo simulation methods, in which the computer is instructed to model the behavior of the portfolio of reference entities subject to defined constraints and parameters, and then the average outcome of a large number of iterations is then used to derive the pricing of the various tranches being issued. CDOs, collateralized debt obligations, which are really basket CLNs but contain dozens or hundreds of reference entities, are effectively priced in this manner. All this and more will be examined in further, more advanced modules. This concludes Chapter 3 and brings us to our quiz.